Hello, everybody. I'm Sherry from China and TrustedFirmware-M project. My focus area is firmware update service. This presentation is about what we did in this field recently. Okay, this is the short agenda of the presentation. Firstly, it's about the PC firmware update APIs spec, which is published by ARM, and then I will introduce the firmware update service in TFM. And the third part of the presentation is about the firmware update service integration with Fratos OTA. Then the last part is about the future plan. Okay, let's start it. Okay. Firmware update support is an essential property of a PC device. However, the mechanism to update a firmware on a device differs significantly across different embedded platforms. ARM published the PC firmware update API spec in February this year, and it defines a standard firmware interface for firmware updates. Okay, I will introduce the APIs later. Okay, before introducing the firmware update service in TFM, let's give a brief introduction about what TFM is. Okay, TFM, whose full name is TrustedFirmware-M, implements a secure processing environment for ARM v8M architecture and dual-core ClassM devices. As an open source project, it is a PSC reference implementation aligning with PSC certified guidelines. Okay, let's look at the system level integrity of TFM. As we can see, the isolation exists between the secure word and the non-secure between the secure word and the non-secure word, and also in PSC isolation level 2 and level 3, the isolation also exists between the secure partitions. The firmware update partition is designed as a PC root or trust service, as it needs to access the critical areas where the images locate. Okay. This is a diagram of the firmware update service module. Inside the firmware update partition within TFM, the image state management module maintains the image state. The image state indicates how much has been done in a firmware update process. To make it easy to put a specific bootloader into this partition, we designed a bootloader shim layer under the image state management module. Currently, we have ported the MCU boot into this partition. MCU boot is used as a bootloader in ARM devices in TFM. So when it boots up, it validates the image and also after choosing a validated image to run, it writes image information in memory which is shared with TFM core. And when the TFM calls the module, the secure partition manager initiate the firmware update partition by calling the init module. The init module in return requests the TFM core to read the shared memory and to get the image information. Okay, and the firmware update client library is about the user interfaces of this service. Okay, this is firmware update service APIs introduction. The PSC FW query interface returns the image information, such as the image version and the image hash information. The PSC FW write interface writes an image to its staging area. This function is called for during the image update, during the image download process. And the PSC FW install interface starts the installation of an image, while the accept interface indicates that the upgrade is successful, and this is the end of a successful successful firmware update process. And the request reboot interface requests the platform to do a reboot. For the detailed descriptions of these APIs, you can refer to the PSC Firmware Update API, which is published by ARM in this link. Okay, this is the image state transition in the firmware update partition. Okay, as the image state transition is very complex, let's go through a successful image state transition in let's go through the image transition in a successful firmware update. Okay, the initial state is undefined. Start from the undefined state, and the switches to candidate state when the image download is started, and when the image download is finished, and it switches to installed state when the PSC success error code is returned in the install API. This indicates that the image has been verified and validated, and this is end of a successful firmware update. Or an alternative way of a successful firmware image is similarly from the undefined state and switches to candidate state to finish the image download, and then switches to the reboot restart needed state. This state is switched because PSA error code, the PSA success reboot error code is returned by the install interface. This error code indicates that a reboot is required to finish the image validation, and the image validation is not finished or is not done within the install interface itself. Okay, after a successful system reboot, and the bootloader verifies this image and chooses a new image as a running image, and then the image switches to pending install state. Finally, it switches to the installed state when the application calls the accept interface to set this image accepted explicitly. Okay, this is another way of successful firmware image update process. Okay, let's go on. Okay, this is the bootloader shim layer APIs we defined to port bootloader or to put a specific bootloader within this firmware update partition. Just needed to implement these APIs according to their descriptions. Okay. 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 The next part of the presentation is about the TFM integration with Fratos OT. To integrate the TFM with Fratos OT, the first step is to enable TFM support within the Fratos kernel. This work has been done in last year, and TFM integration with Fratos kernel based on V8M has been supported in Fratos kernel's official repo. And this is the next step, as the TLS connection is essential in an OTA process, and the OT the TLS library in Fratos OT calls PCS11 library to do some cryptographic operations. So we implemented the TFM-based PCS11 library in a standalone repo, and this repo has been cloned into Fratos repo by some module in the submodule way. Okay, and finally, the integration with Fratos OTA is still a work in progress. Actually, the functionality implementation and has been finished, and we have verified this integration with AWS cloud. But the integration upstream is still in progress. Okay, let's look at the details of the integration firmware update service with Fratos OTA. Okay, as you can see, the NiceCore process environment runs applications while TFM runs in the secure process environment, and on the NiceCore world, the OTA application calls the OTA library to achieve the firmware update over the air, and within the OTA library, the OTA agent communicates with the AWS OTA server based on the MQTT and the HTTPS connections. Both of these connections are based on TLS connection, and the TLS library calls the TFM service by calling the PS functional APIs. Sorry, and also within the OTA library, the OTA agent controls the firmware update process, and it calls the OTA platform abstraction layer to do specific image update operations. This OTA platform pod layer calls the TFM service by calling the PSA functional APIs. Okay. Okay. This is the mapping of the functions between the OTA PAL APIs and the PSA functional APIs. Note that the OTA PAL APIs are defined in the left side are defined by the Fratos OTA itself. Okay. Let's go through successful TFM protected Fratos OTA process. Okay. Firstly, the NetSecure side, the NetSecure device side on the device request to establish the TLS connection, and during this process, the TLS library calls PS crypto service to do some cryptographic operation based on the private key, and finally the DS connection is done, and then the application calls MQTT library to establish the MQTT connection based on the TLS connection. Okay, after the MQTT connection established is done, then the application calls the OTA library to request the OTA job based on the MQTT connection. And then the AWS server notifies the device that there's a new OTA job, and in this job, it describes that there's a new image which is waiting to be updated over the air. Okay, then the OTA library starts the image download process. In this process, the OTA library calls the TFM firmware update service to read the to download the image days into the staging area block by block. Okay, after the image download is finished, then the OTA library starts the signature check process. In this process, it firstly calls the query interface to get the image hash information, and then calls the crypto service to verify the signature. The one point I should emphasize that this signature is from the from the AWS OT server side, and it is contained in the OT job. Okay, and also within the firmware update service, when calculating the image hash, we did not use the data block directly from the network side. Instead, we, as though the image download has been finished, we read the image data out from the device and calculate hash based on the read out date. So the signature check process ensures that the image is truly come from the AWS OT server, and also the all the data blocks of the image are are downloaded and the right address in the staging area. Okay. Then after the signature check process, the OT library start the activate image process. In this process, it calls the install interface to start the installation of the image. Based on the MCU boot within the firmware update service, based on the MCU boot bootloader shim layer, it returns a reboot needed error code as we introduced before. So to request to indicate that a reboot is required to complete the installation. So the OT library, based on this error code, requests the device by calling the request reboot interface, and then the system reboots. After booting up, the MCU boot the bootloader with the MCU boot start runs, and the validated image and choosing a validated image to boot up. And then when the NASCAR application starts running similarly with the previous process, the TLS connection is done, and then the Encrypted connection is established, and then the OT library requests to the server a new OT job, and then the OT server notifies the device that there is a new OT job. But in this job, it describes that a self-test should be done. It's not this job is different from the former one. Okay, and okay, then after receiving this job, the OT library start to check the image version. Firstly, it calls the query API to get the image version with a running image, and then it compares this version with the version of the image which runs before the reboot. So if the former version is newer than the later one, then this is the newly downloaded image is inactive. It is a validated image. Okay. Then finally, the OT library says the image as accepted. Finally, the image says the image accepted explicitly by calling the accept interface. Okay, this is the end of a successful OTA process. Okay, good. And these are some of the tests we did with AWS Cloud. As you can see, we did different tests under different configurations within TFM. We tested the secure image update and the non-secure image update separately, and also we did a test under different TFM isolations. Okay, just picked some of the test result shortcuts from the AWS cloud. Okay, so what is protected in the whole OTA process. Firstly, in the TLS connection process, the private key is protected by PS crypto service and the PS internal trusted storage service. The data of the private key is not exposed to NASQL, and NASQL can only get the key handle to do the cryptographic operation based on this key. And in the OT in the later OT process, it protects the image in the staging area from being tempered with by the NASQL processing environment. After the image is downloaded, is written into the staging area, the NASQL has no access to that area, and so it cannot be tempered by the NASQL processing environment. And also similarly, it protects the active image, I mean the running image, the currently running image from being manipulated by the NASQL processing environment. Okay. Okay. Then the last part of the presentation is about the future plan. The first one is about we will add the firmware update partition to the next TFM release, which is planned to happen in the next few days. Actually, this partition implementation has been merged into the TFM master branch. Okay. Next, as we mentioned, the integration of TFM firmware update service with FreeRTOS OTA layer is not upstreamed. Its implementation has been finished, and we have verified with a cloud as shown, and but the upstream work has not been finished, and we will complete that work following. Okay, the last point is there may be some updates in the PSA Firmware Update API spec, which is published by ARM, and we will align the firmware update partition, and also the integration with the FreeRTOS with the future update if there is. And okay. This is all about my presentation today. Okay, any questions?
Sherry, there are a few questions in the chat.
Okay.
So the first one is encrypted firmware image supported?
Yes, but this yes, the answer first is yes, but actually the whether the image is encrypted or not is makes no difference in the firmware update implementation based on the MCU boot because when we put in the MCU boot into the firmware update partition, the when we start the image installation, the TFM firmware update partition just marks the image as a candidate image. So and then request and then return the error code to request a system reboot. The image decryption and validation are all done with by the bootloader when the device reboot. Okay.
Okay, I think we've got time for one more question, and then we can follow up with the other one after the session. So the next one is there a revocation mechanism so that certain images are never flashed?
Yes, we will have a revocation mechanism. okay. I think I did not list that phase. There's a API called PAC FW about which about the firmware update process, and but we and that will erase the downloaded images in the staging area if there is, and then I do not know whether this is the expected reversion mechanism.
Great. And then one final quick question. Is it possible to update MCU boot?
Update MCU, no, this firmware update can only update the TFM image, I mean the secure image, and also the NASCAR image. The bootloader itself cannot be updated via this service.
Okay, great. Well, thank you so much, Sherry. In that case, anything else to add?
No more from my side.
Okay, great. Thank you everyone for joining.
Thank you.